Hi, welcome to another Algebra 1 video. In this video we're looking at section 3.5, which is about graphing linear equations in slope-intercept form. In this video we will learn about the slope or gradient of a line, and we will learn about graphing linear equations using a new form, which is the slope-intercept form. From our basic concepts of linear functions, we know that a linear function can be written in the form y equals mx plus b, where the y is the dependent variable and the x is the independent variable, and m and b are constants. From previous videos we learned that linear functions, when graphed, they can look like different lines. You could have a line that looks something like this, or you could have a line that's in the opposite direction. You could have a flat line, or you could have a completely vertical line. The equation form that we're most familiar with graphing linear functions is y equals mx plus b, which is also known as the slope-intercept form. The reason why this form is called the slope-intercept form is because the m part of this equation is the slope or the steepness of the line, and in other countries you may also know it as the gradient of the line. And the second part of the naming is the b, which is actually the y-intercept of the line that you graph. So if you have a linear equation that says y equals to 2x plus 1, then the 2 is going to be your slope, and the 1 is going to be your y-intercept. You can graph the y-intercept of this line by plugging in 0 for x. So in the equation y equals to 2x plus 1, if you plug in 0 for x, you get 2 times 0 plus 1, and the 2 times 0 cancels out because anything multiplied by 0 is just 0, and you're left with y equaling to 1. So this tells us that when you have the x-coordinate of 0, you get a y-intercept of 1. Because at this point of 0, 1, which is this point if you graph the linear equation, you cross the y-axis, so this point is 0, 1. Another equation that you could have is y equals to negative x minus 2. In this case, you know that negative 1, which is the coefficient of x, is your slope. And the negative 2 that follows the coefficient and the variable is your y-intercept. As we know from the equation form that b is your y-intercept. The coordinates of y-intercepts for any equation are given in the point of 0, b, where you plug in 0 for x and you get some value b, which is this part. So let's plug in 0 for x in this equation. So our equation is y equals to negative x minus 2. And we can plug in 0 for x, so we get negative times 0 minus 2. So y equals to negative times 0, which is simply 0, and we're left with negative 2. So we get negative 2, which is indeed our y-intercept, as this is the b part of the original equation. And if you graph the line y equals to negative x minus 2, then your y-intercept will be at the point of 0, negative 2, which is this point on this graph. Another equation in the slope-intercept form could be y equals to 4. In this case, we don't know what the slope is. It's not obvious right from the equation. But you can also rewrite this equation as y equals to 0x plus 4. Because 0x is just 0 and you're left with 4, so we're not changing the equation at all. In this case, we can say that the slope is 0. So this coefficient is our slope. And this 4 that we have here is our y-intercept, because we know that this is our b part of the slope-intercept form. So this is our y-intercept. And for this equation, you can prove that 4 is going to be your y-intercept, because when you plug in 0 for the equation, for your x value, you will get 4 for your y coordinate. So in the equation y equals to 4, or y equals to 0x plus 4, which is the same thing, if you plug in 0 for x, you get 0 times 0 plus 4. And we know that 0 times 0 is just 0, so you're left with 4. So your y-intercept is at the point 0, 4. Another way you can see that y4 is your y-intercept is that you can only plug in 4 for your y value to satisfy the equation. So if you plug in 4, you get 4 equals to 4. Therefore, you can't have any other value to satisfy this equation, because only 4 satisfies this equation. You can't have 3 equals to 4, you couldn't have 0 equals to 4, or any other number besides 4. So that's why 4 is your y-intercept. And if you look at this line that we graphed here, this point should be 0, 4. So this is our y-intercept for this line. Also note that on this line, we had no m value, it was 0, and it's also why we had a flat line. So far we've only talked about what the y-intercept really is. We haven't really gone into slope or the gradient of a line. The slope or gradient of a line is a measure of how steep or the incline or decline of a line is. In the slope-intercept form, we know that the equation is written in the form y equals to mx plus b, and the slope in this equation is represented by the letter m. On a graph, the slope of a line is at the rate at which the y values change as you change the x values. So if you change the x values by an amount of 1 unit, then this y value increases by an amount of 1 unit as well. If you keep doing that, you can see that there is a pattern. As you increase x by 1, you increase the y by 1. If you increase x again by 1, then you increase y by 1 again, and so on. Whereas if you looked at a line that looked more steep, then you can measure the slope by using the same process. If you run a value of 1 along the x-axis, then you can see that there's more y value that you get from that. And this y value is about 2.5. If you do that again, then you increase by 1x and you go up by 2.5. So this line has a slope of 2.5. Now in mathematical terms, the slope of a line is represented by the letter m, and that m is represented as the change in y over the change in x. In general terms, the change in y over the change in x can also be represented as the rise over the run, which are some general terms to understand the slope of a line better. So let's say you pick 2 points on a line. On this line you can rise by this value, and then you can run for this value to reach that point. So in this first case, let's say that we rose by a value of change in y equaling 3. And let's say you ran, which is your change in x, by a value of 1. Then you can use these two quantities to find the slope of this line. So we know that the m is equal to the change in y over the change in x, or the rise over the run of the line. So the slope in this case would be the change in y, which is 3 because you climb by 3, and then you step forwards by 1. So your change in x is 1, and therefore your slope, the m, is equal to 3. But when you're talking about the slope of a line, you're not always given your change in x or the change in y for the line. You may be given 2 points, which you can use to find the slope. So in this case we have 2 points, -3, 2, and 4, -5. So in this case I can see that instead of rising, our rise is going to be negative because we're going downwards. And then our run is going to be positive because we're heading towards the positive direction, as the positive numbers are on the right side of the number line. We know that our slope is represented by the change in y over the change in x, and in this case our change in y would be this vertical line, as our y value changes from 2 to -5, and this horizontal part is our change in x, as we change from -3 to 4. Now coming back to the formula m equals to change in y over the change in x, we can change the change in y as the secondary y minus the first y, and we can also change the change in x to x2 minus the first x. So we can use the coordinates that we have here to find the slope of this line. In this case, let's say that this point is represented by the point x1, y1. So our x1 would be -3 and the y1 would be equal to 2. And in this case, let's say that this point is equal to x2, y2. So our secondary x point is 4 and our secondary y point is -5. Now all we have to do to find the slope of this line is to plug in the numbers for x2, y2, x1 and y1 into this formula and then simplify to get the m value. So we know that the change in y in this equation will be y2 minus y1. In this case we said that our y2 is equal to -5, so we can plug in -5 for y2. And our y1 coordinate in this case is this 2, which is part of -3, 2, because we label this as the first y value. So we get -5 minus 2, which is from the y1, over the change in x. And our change in x is x2 minus x1. So our x2 in this case is this coordinate, which is 4. So we can plug in 4 here, minus the x1, which is in this case -3. So we get 4 minus -3. And then we just have to simplify this. So -5 minus 2 is -7. And 4 minus -3 is like saying 4 plus 3, which is 7. And -7 over 7 simplifies to -1. So our slope, or the m, or the gradient of this line is -1. And this m value of -1 makes sense because you're heading downwards in the opposite direction. You're not going upwards, because if you were going upwards, you would have a slope that's positive. And in this case, since we know that our change in y over the change in x, which is also your m, is equal to -1 over 1, this means that if you run by a value of 1, then your y value on the line decreases by 1 as well. So on this line, let's say you move by a value of 1, then you're also dropping down by a value of 1. And this makes sense because here your rise was -1 and your run was 1. So your slope would be -1 over 1, which is -1. Now to summarize everything, let's graph some linear equations in the slope-intercept form. By now you may know well that the slope-intercept form is an equation that consists of the slope and the y-intercept. And an example of that line could be y equals to -3x plus 0.5, where our -3 would be the slope and the 0.5 would be our y-intercept. Another equation that you could have is y equals to 2x minus 1, where 2 is your slope and the -1 is your y-intercept, the point at which the graph crosses the y-axis. Let's graph the equation y equals to -3x minus 1. So right away you know that from the slope-intercept form, which is y equals to mx plus b, our slope in this equation would be -3, as -3 is the m in the slope-intercept form, and our y-intercept would be at 0, -1. because our b value in this case is -1. So we already know that the first point would be at 0, -1, which is also your y-intercept. So 0, 1 would be at this point. From the equation, we also know that the slope is -3. So this means that the change in y over the change in x would equal to -3 over 1, which is simply equal to -3. So for every run that you do, which is equal to 1 value, you go down by a value of 3. So from the point 0, -1, which is our y-intercept, let's go forward by a value of 1, which is our change in x, and then we can go down by 3, which is at this point. So this is our next point on this number line. So we increased our x value by 1, so 0 plus 1 on the y-intercept would give us a new x value of 1. And then we did a rise by -3, so -1 minus 3 gives us -4, and therefore our new point is 1, -4. Now let's run again by a value of 1, which will land at this point, and then we can go down by 3 units because our change in y is -3, so we get to a point which is here. So we ran by a value of 1 along the x-axis, so our new x value would be 2, and our y value in this case would be -4 minus 3 because our change in y is -3, and -4 minus 3 is -7. So this is our new point. Now let's graph a point that's behind the y-axis. To graph a point that's behind the y-axis, you have to multiply the slope that you have, which is in this case -3 over +1, by -1 over -1. And if you do that, you get -3 times -1, which is +3, and your change in x would be 1 times -1, which is -1. And we haven't changed the slope because all we did is bring the negative sign to the denominator instead of the numerator, so both of these still equal to -3. So to graph the point behind the y-axis, we will run backwards with a value of -1, so 0 minus 1 would be at this point, and then we have to increase our y value by a quantity of 3. So if we increase by 3, we get 1, 2, 3, which lands us at this point. And if you connect the dots with the ruler, you get something that looks like this. And the point that we graphed behind the y-axis would equal to -1, 2. Now a thing to note about graphing in this way, by using the slope and the y-axis, is that you haven't wasted your time looking for coordinates by plugging in x values in a manual way. In fact, instead, all you have used is your change in y and the change in x, which is also your slope, and the y-intercept, which is a predetermined point for every linear equation. Now in this case, I've graphed 4 points, but in actuality, all you need are 2 points to graph a linear equation. So if you were to graph another equation like 2x minus 1, then you'd only have to plot the y-intercept, and then you can use the rise over the run logic to graph the second point, and then you just connect the 2 dots with the ruler, and you end up with the linear function that's completely graphed. And this is it for section 3.5. I hope you now understand the concepts of the slope-intercept form, which is y equals mx plus b. You understand how to find the slope and the y-intercept of some line, and also how to graph a linear function by using your slope and the y-intercept. Leave a like if you found this video helpful, and subscribe for more videos in the future. And I'll see you in the next video. Thanks for watching.